this question, and I'll have you just present the question carefully. A ring of radius smaller and a small ball of same mass are placed on frictionless horizontal floor. The ball is at a distance 0.5 r from center of the ring. Now both of them are given opposite velocities of equal moduli in the directions perpendicular to the line joining the center C of the ring and the location B of the ball. All the collisions between them are perfectly elastic. Now the questions are to draw the trajectories of the ball and the center of the ring. So we have to find out the trajectories followed by the ball and the center of the ring after the collisions, and find the minimum and maximum separation between them during the process of their motion. So that is the thing that we have to find. So first of all, now I'm going to start here, and one more point is missing in the diagram. So that is the distance between the ball of mass m and the center of the ring is given as 0.5 r. So this is the thing given in the question. So now let us see how to solve this question. So I'm going to start attack on this question from the concept of center of mass. So now I'm going to calculate the velocity of the center of mass of the system. So velocity of the center of mass is m1 v1 plus m2 v2 divided by m1 plus m2. This is the velocity of the center of mass. So let us see here, the mass of the ring is m, and the velocity of the ring is, it is towards right, and it is u. So you are going to take it as positive. And the velocity of the small m is minus u, because it is also having the same mass, but velocity is opposite. So denominator we are getting 2m, and the velocity of center of mass is finally becomes 0. That means the center of mass of the ring mass system, this is a ring and this is the mass. For this ring mass system, we can consider this is the position of the center of mass. It is exactly lies at a distance of 0.25 r from the center. So it is exactly in between the mass and the center of the ring. This is the center of mass, but the center of mass of the system is not at all moving. It is at rest. So if you observe the entire system from the center of mass point of view, the picture will be very much clear and also very simple. So now let us see how to solve this question from the center of mass frame point of view. So we have to observe the diagram of the problem after the ball m starts moving towards left. Okay, see here, I have already plotted that diagram. See, the ball of small m is given a velocity u towards left, and the center of the ring will move towards right with the same velocity. And this is the point where the center of mass is located, and of course its velocity is 0. And you have to see here the situation is very much clear. So the point A on the ring will also move towards right with the velocity u, because every point on the ring will move with the same velocity u. So we have to notice that point. Whenever the center of mass of the ring is moving towards right with the velocity u, every point on the ring will also move with the same velocity. So the ring will move with the same velocity u towards right. The point A is also moving towards right with the same velocity u, and C, the particle is also moving towards left with the same velocity u. So here the problem becomes a little bit easier. So we have to calculate where the ball is going to get collide with the ring, at which distance it will get collide with the ring, that we are going to calculate. So for that I am just going to take out this distance. I want this distance of separation. So we can see here clearly this is already given as 1 by 2 r. So, and this angle theta is very much important here to calculate. So first of all, I'm going to figure out the value of theta. So by taking cos theta, I can get the value. Cos theta is OB by AO. So OB is half into R, AO is R. So cos theta will be 1 by 2 R. R will get cancelled, and we are getting cos theta will be 1 by 2. So here the theta is 60 degrees. So that means this angle theta is 60 degrees. So we can easily compute AB from that knowledge. So we can take the sine theta. Sine theta is opposite side, that is AB, divided by hypotenuse, that is AO. So AB is equals to AO into sine theta. So that we can get. But already we know that AO is R and sine 60 is root 3 by 2 because theta is 60 we know. Okay, we got the value of AB. So we can now use the formula, that is distance, that distance is AB is equals to V relative into time. So here the idea is to find out the time after which the point A on the ring and the mass which is at the point B will get collide. So we are going to find out that time. So the time can be directly calculated here. So distance AB is known, that is root 2 into R by 2, and the relative velocity, because these particles, the particle present on the ring and the particle B are moving opposite direction, so the relative velocity will be 2u. So time at which they will meet will be root 3r divided by 4u. This is the time after which A will meet the B or B will meet A. Both will collide. So I have clearly shown you that situation. It is a different diagram. So I have shown you that situation, and we can see clearly A and B are traveling with the same speeds but in opposite directions. So both will definitely cover equal distances in this time t. So we have to notice that point very much clearly. So here the distance traveled by the point A is AC, that is root 3r by 4, and the distance traveled by the point B, that is BC, this distance is also root 3r by 4 because they are traveling with equal speeds but in opposite directions. And see, the situation is very clear. Whenever the point A on the ring moving through the distance AC, the center of the ring will move the same distance towards right. So this distance is also root 3r by 4. And you have to notice that at point C, the particle of mass m will collide with the ring. And this collision they have given as a perfectly elastic collision. If the collision is perfectly elastic, we can see the angles are same. The angle at which it is colliding, let us say that angle as alpha. I am zooming for that purpose only, I am zooming it. You can see that angle also. So this is the angle alpha at which the particle is colliding. So you can see I have taken a dotted line from the present position of the center of the circle. From with that dotted line, the particle is making angle alpha. Okay, with the same angle it will reflect because the collision is elastic. If the collision is elastic, angle at which it is colliding is equals to angle at which it is reflecting. So both are alpha, and the particle after collision here, what the particle will do? Particle will reflect like this and it will travel in this direction. Okay, but at the same time, the ring will also move in opposite direction. In this way, the ring will move because the collision is elastic. Ring will move in opposite direction. So whenever the ring is moving in opposite direction, the center of the ring, the center of the ring will also move in the same direction. So that point we have to observe, students. I have shown you that one clearly. Just I will show you just a second. So you can see here clearly, whenever the particle is moving from C to C, particle after collision it is moving like this. The ring, this ring will also move like this because it is also moving with the same speed. The particle after the speed also doesn't change because the collision is elastic. The speed is u only. The particle is moving with the same speed u in this direction. It is moving like this. At the same time, the ring is also moving with the same speed u. in opposite direction like this. So somewhere here at point D they will get collide, because again they will get collided because they are moving in opposite directions. Again there is a chance of collision here. So you can see, so I have shown you that one also with the diagram, and here we have to identify how these centers are moving, center and the particle B are moving until now. First of all, the center is located here, and first of all it has moved some distance like this, and this distance is root 3 r by 4. Next, here the particle is there, the particle is B, and that is moving towards left, and you have to see here how it's moving. It is also covering the same distance, that is root 3 r by 4, and this is the point where the center of mass is located. And after collision at the point C, this is the point C, the particle is reflected like this, and the collision is perfectly elastic. And whenever the particle is moving like this, the center O of the ring will also move like this. So it will also move like this. You can see they are equal only. They will definitely travel equal lengths once again. And here is that diagram. You can see clearly here in this diagram, after collision at the point C, the particle started like this and it has traveled like this. So it is targeting towards the another point on the ring, and you can see clearly this is the new. I have taken one triangle here. You can clearly see. So this is radius r. This is also radius r, and the opposite angles are definitely equal, students. If this is 60, this angle is 90, and this is 30, and this is 30. Again, I already told you this alpha we are getting here. The alpha value we are getting is 30. So this is also 30. So again, this angle is also 30. So here also we are getting 30 because so the radius is same. The opposite angles will be equal. So this angle is 30. So this angle 30, this angle is also 30. So you can see clearly the distance C. Well, the particle started after collision. Particle is started after collision at point C, and it is traveling like this with the speed u. And see here, we have to observe at what time again it will collide with the circumference of the ring. So that we have to find. And we know already their speeds are same, and you know the distance of separation between the circumference and the point C. So that distance of separation is root 3r, because whenever we are having a triangle like this, with this is r and this is r, and you can clearly see here, and you just observe this point very clearly. This is 60, and we got this is 90, this is 30, and this is 30. This is also r. If this is 30, this angle is also 30, students, because this is r and this is r, so opposite angles are also equal. So this is 120. So opposite side of 120 will be definitely root 3r. Okay. So this is the point C. See, you have to notice one important thing here. The particle is reflected from the point C like this, and it is moving with the speed u. It's moving like this. And again, you can see the circumference of the point on the circumference of the ring is also moving like this. I'm going to show you with a different color. It is also moving like this. It is also moving. But at the point D, you can see at point D, they are going to get collide. Again, at point D, they are going to get collide. So we have to notice that point very clearly, because both are moving with the same speed, but again in opposite directions, and they are going to get collide at point D. So here again, you can directly apply distance is equals to v relative into time. So distance is now it is root 3r, relative speed is 2u into time t. So you can clearly notice that the time at which they will collide is root 3r by 2u. So now this time the distance traveled by the particle from C to D is root 3r by 2. At the same time, the distance traveled by the point on the circumference of the ring in this direction, it is also root 3r by 2. At the same time, the center will also move. Whenever it's moving like this, the center will move downwards, because we have already seen here at this point the center is here. But whenever it is moving like this, the center is definitely moving downwards like this. Center will definitely move downwards. So you can see the diagram very much clearly. So this distance from C to D, so this is root 3r by 2. The center is also moving downward, the same distance, root 3r by 2, and the center will reach to this point. Again, at point D, you have to observe one thing. It is undergoing collision with the circumference of the circle whose center is located at point O. Whose center is located at point O. Center located at point O, and it is undergoing collision at this point. So this is the situation. So this is the center of what? Center of the circle, and this is the particle getting collided. Again, after this collision, the particle will move the same distance here, like this, and exactly the center will also move oppositely like this. So you have to notice by the same amount, by the same distance. It's moving like this, and again the cycle will repeat. Again it will undergo collision here. Again it will start its motion like this. Again it will collide here. Again it will start motion like this. And finally you have to observe the final trajectory. I have already shown you the final trajectory also, so you can clearly see how it is happening. It's very clearly here. So this is what happening here. So this is the paths, the final trajectory of the point B and the center O. So if you observe from the center of mass point of view, the picture appears like this, and the distance of the point O and the point B is originally it is 0.5. That is the minimum distance. So minimum distance of separation between center of circle and particle is 0.5 r. But what about the maximum distance of separation? You can see the center is there here, and this is the particle, and this is 0.25, and this is also 0.25 only. You can calculate by using the geometry of the diagram, and we will get this one also 0.25. And you can see the maximum separation between the center of the circle and the particle. This is the particle, and the particle, the maximum separation between center of circle and particle is 0.25, 0.25, 0.25, 0.25. That is 4 times 0.25 into r. So that will be r. So this is the solution for the question. It is completely geometry based question, and also it is based on a lot of imagination. So in order to solve this question, we require little imagination. So we have to know what we're doing here from the center of mass frame. Then the question becomes very easy. So that is the way I have solved this question. So this is the solution, students. Hope you enjoyed it. Okay, thank you.